Greetings everybody. Here's a problem right off the MyMathLab assignment that stands out to me, okay? And I'll tell you why it stands out to me as I work it. So it says use the product rule, okay? So I'm given these specific instructions to find the derivative of this function. Okay, g of t 4, 7t squared, 5t 4 times root t. Now, my take on this is, I guess this is a matter of opinion, but I don't think the product rule is the easiest way to go. Okay, I say that's a matter of opinion because whether something's easy or not is a matter of opinion. So I'll show you another way to do this without the product rule. That's perfectly fine if you do things like this. It might say to do one thing, like to use one rule, but if you can find a way to make another rule work, I think that that's fine. Okay, so let me show you my take on this. I see that I could just multiply all this stuff together and then I wouldn't have to use the product rule. And I do think I get an easier situation if I do it that way. So here's what I mean. So let's see, I got a 4 and I've got root t, but I'm going to write that as t to the 1/2 power, then times 7t squared plus 5t plus 4. Okay, now what I'm saying is I can multiply all this together. I can distribute 4t to the 1/2 power upon each term there. Okay, so when I do that, I get 4 times 7, that's 28. But how do I multiply t to the 1/2 power times t squared? Well, so when we do calculus, most people find that we've got to get good at algebra, even if we weren't so good before. So like I've got to get really comfortable with all the rules for exponents, especially from algebra, in order to rewrite things, get them in easier forms, simplify them, and so on when I'm doing calculus. So back to what I was saying. What is t to the 1/2 power times t squared? Well, in algebra, we learn this. When we multiply like things, we add exponents. So t and t, okay? T to the 1/2 times t squared, I need to add those exponents together. And 1/2 plus 2 is 5/2. I'm going to continue. 4 times 5 is 20. What's t to the 1/2 times t? Well, again, when I multiply like things, I add the exponents. 1/2 plus 1, 3/2. Okay? And then 4 times 4, 16, and just t to the 1/2. So I'll work on this. So you could say the original function g of t was what you were given. You could say it's this, what I have in my first step, or this, what I have in my second step. It's any of those that you want it to be. But I think it's easiest to work with this one. I don't have to use the product rule anymore. I can use one of the most basic rules for derivatives to find the derivative of g of t as you see it right here. Here's what that rule is. Remember, the derivative of some variable to a constant power, you bring that power to the front as a coefficient and you subtract 1. Okay, so here's what that looks like. First, that coefficient carry down. 5/2 goes here. 5/2 minus 1 is 3/2. Carry down the plus, carry down the 20. 3/2 goes here. 3/2 minus 1 is 1/2. Carry down the plus, carry down the 16. 1/2 here. 1/2 subtract 1 is negative 1/2. Okay, so that's not too bad. From here, I'll do some simplifying. 28 times 5/2 is 70. 20 times 3/2 is 30. And 16 times 1/2 is 8. One last thing. I notice this exponent's negative, so I'll put it under the bar like that. I'll write t to the 1/2 power positive. Okay. So there, and I think that's an okay answer. I know it's not the answer I see on MyMathLab. And, I think this is fine. I also think that you should know how to write things in different ways. It's just part of being good at math once you go to calculus and beyond. So I see this, and I'm saying that's okay. I think most of the time, anybody who's wanting you to do this for whatever the purpose is would be fine with this answer. But at the same time, I'm saying we should know how to get that one. We should know how to make these agree with each other. Okay? So let's see. How can we get some agreement between this answer, which I just got, no mistakes, it's correct, to the answer on MyMathLab? Okay, so here's what I noticed I could do in addition to what I already have. I see this is a fraction, and I guess these are too if you put a 1 under them. It looks like everything was added together there. So how am I going to add these fractions together? Well, I'm going to have to get a common denominator for that to happen. That common denominator is t to the 1/2 power. So look, I took this first term, this first fraction, multiplied by t to the 1/2 over t to the 1/2. I'm multiplying it by 1. Did you know when you do this to get a common denominator, all you're doing is multiplying by 1. You're not changing the number that you have. Any number you have times 1 is going to be the same number, but it will look different and it will be compatible to adding here. Okay, so I'll do this and I'll do this likewise to get a common denominator there, and I'll leave this one alone. So what am I going to have? What's 70t to the 3/2 times t to the 1/2? Remember how I talked about we need to get good at algebra. We need to be flexible. We need to rewrite things. We need to know what all the rules of exponents are. Well, so that rule of exponents that I mentioned earlier was when I multiply like things, I add the exponents. The exponent here is, what's 3/2 plus 1/2? It'll be 4/2. What's that? That's just 2. So this is 70t squared, okay, plus, okay, what's 30t to the 1/2 times t to the 1/2? Well, once again, multiplying like things, you add the exponents. This is 30t, or whatever 1/2 plus 1/2 is, which is 1, and then plus 8 over t to the 1/2. Now we're almost there, not quite. How do you think they made the jump from where we are to the answer that's in MyMathLab? I could factor out any greatest common factor among 70, 30, and 8, which is 2. And I could rewrite this 1/2 exponent as a square root. They're the same thing after all. Okay, that's how I approached this in the beginning. I said, I'll write root t as t to the 1/2 because that makes it compatible with multiplying all these other things. So I'll get 2 35t squared plus 15t plus 4 over root t, and then you see that's the answer that I was given. All right, so you may not like it, but that's very much of what we need to do right now. We need to know the rules of algebra. We need to work with exponents flexibly. We need to perhaps take something and rewrite it some other way and then work on it. We might need to get some answer and simplify it. All that will be really important as you learn calculus and go further.